For problem number 6, I wanted to continue with this problem by selecting the correct labels for the axes of the graph. So we're going to select the correct choice from each drop-down. The label for the x-axis is going to be the number of sandwiches. And the label for the y-axis is the cost of the order, also known as like the total cost. Part D is there a proportional relationship between the number of sandwiches and the cost of the order? We are going to select yes, there is a proportional relationship. And we know this because as X or number of sandwiches increases, Y, also known as the total cost of the order, also increases. There is an additive constant of $4.50 for every one increase in sandwich order. Part E. At a different sandwich shop, there is a $5 delivery fee, and each sandwich costs $4.50. On the same grid, you're going to graph the total cost of sandwiches and delivery based on number of sandwiches ordered for this new shop. And we're going to describe how the two graphs are the same and how they are different. Well, before we graph this equation, we're going to write an equation for it. So y equals $4.50. Again, this is the additive constant, which is also our slope. I'm going to place it next to the x, which stands for the number of sandwiches ordered. And we're going to add the $5 delivery fee to it. So the difference here is that instead of having a $10 delivery fee, it's only going to be a $5 delivery fee. But what's the same is that the slope is still $4.50. They didn't change the price of this sandwich. Now we're going to graph it on the same grid. And if you remembered, I had written the x-axis as increasing by 1 every single time. And for the y-axis, I was increasing this by 2 every single take mark. Now we're going to graph y equals $4.50, x plus 10, and our new equation of y equals $4.50, x plus 5. Now earlier we saw that this first equation over here, I'm going to graph it in pink. We started with our y-intercept of 10 and we increased it by 4.5. So from 10 to 4.5, we have 14.5. And we said that if this is 15, 14.5 is in the middle of 14 and 15. So this was our new point here. And if we continued with this pattern from 14.5, I can add another 4.5 if I have 2 sandwiches, and it goes up to 19. So for 2 sandwiches, it was 19, and this was what our line had looked like, and it continues, which is why we drew an arrow at the end of this line. And I'm going to label this as y equals 4.50x plus 10. And in a different color, maybe in green, I'm going to graph the second equation, where we have a y-intercept of 5 instead of 10 because the delivery fee is only $5 instead of $10. This is even before we order any of the sandwiches. So we are going to start at 5 and increase by 4.50 for every additional sandwich that we order. And when we add 4.50 to 5, we end up getting 9.50. So let's go ahead and graph that. In the middle of 8 and 10, we have 9. 9.50 is going to be in between a 9 and a 10. I graph that right there. And I'm going to keep going. So what if I ordered 2 sandwiches? Now I'm going to add a 4.5 to 9.50 or 9.5, and I have 14. So I'm going to go all the way up to 14 for the 2 sandwiches. And from 14, I'm going to add another 4.5 for 3 sandwiches, and that gives me 18.5. Now that's going to be between 18 and 19. And it's right over here. And I'm going to do my best to connect these points. You can see here that that is the graph for the second equation. And we already talked about some similarities and differences. You can see that the lines are parallel to each other because they have the same slope. Parallel lines always have the same slope because the price of the sandwich did not change. But we can see that the green line was shifted down 5 units because it's a delivery fee of 5 instead of 10, so the y-intercept is 5 instead of 10.